These small planks of wood represent piles being driven into the ground. The small wooden dowels will allow us to see how individual soil particles will react under these loads. This demonstration shows punching shear. Punching shear failure involves poorly defined shearing planes. It consists of significant compression of a wedge-shaped soil zone beneath the foundation. There's also an occurrence of vertical shear beneath the edges of the foundation. This demonstration shows general shear failure. General shear failure is defined by slip surfaces extending diagonally from the side edges of the footing downward, through the soil, then upward through the ground surface. The ground surface adjacent to the footing bulges upward. Here you can see the soil particles shearing across each other, causing a shear plane. This failure causes bulging on the surface of the soil. This demonstration represents local shear failure. This represents a transitional mode between general shear and punching shear. Local shear forms shear surfaces beyond the edges of the foundation, but they fade into the soil mass and do not carry upward into the surface. You can see the shear surface being formed, but notice it does have an endpoint in the soil mass and does not make it to the surface. This demonstration represents a load being placed next to a retaining wall. This is the same demonstration, except this time sandpaper has been added to the wall to add friction to the surface of the retaining wall. Notice the wall did not shift as much because friction between the soil and the retaining wall provides greater stability. Here you can see that the wall with a smooth surface shifted about 14 degrees, while the wall with added friction shifted only about 7 degrees.